I'm Rakib, and today I'm going to be talking to you about binary search. Alright, so binary search is an algorithm that you can use when you want to find the position of a specified target value in a sorted array. So basically the way it works is that you progressively have the amount of data you have to look through with each iteration. This is done by keeping track of three positions: the position of the smallest value in your search window, the position of the largest value in your search window, and the midpoint. So for each iteration of the search, you want to compare the target value with the value of your midpoint. If they're equal, you can stop the search, but if they're not, you have to decide which direction you want to have the search window in, which is why the array needs to be sorted. So I'll give you a quick example right here. So for example, if you're trying to get the position of the value 6, and your starting array consists of values from 1 to 9, your midpoint will be at the value 5, or index 4. So you compare 5 with 6 because 6 is the target and 5 is the current midpoint. And since 5 is obviously smaller, you can move up the starter search window to the index to the right of the midpoint. So in code it looks like array mid less than 6, then start equals mid plus 1. So the new search window looks like 6, 7, 8, 9. The midpoint is the value 7, so since 7 is greater than 6, you bring the end of your search window back to the index to the left of the midpoint. So if the array mid is greater than target, end equals mid minus 1. So now both your start and your end are at the same indexes, and of course since the midpoint is found by taking the average of these indexes, the midpoint is also there. So we have found the target. Binary search has a worst case runtime of O log 2n. This is because the amount of iterations in the worst case is the number of times it takes to get to one value after dividing the amount of elements by 2 each time. Alright, so now it's time to show you how you can use it on a Leetcode question. Time to do the Leetcode problem. So first, let's look at the question. So we need to find a target value. Like, we need to return its position. Otherwise return 1, so -1 I mean. But the only thing is, the array is rotated, right? So instead of just being like fully sorted, it is sorted, but in two different parts. So you have the bigger side on the left, and then you have the smaller side on the right. And you don't know where the smaller side starts and the bigger side ends. First things first, in order to find the target value, we're going to have to figure out which side to sort on. But to do that, we need to actually find the smallest value because, well, that'll let us actually search it. So we can either search from the beginning to the smallest value, from the smallest value to the end, depending on how the end value compares to target. Alright, so in this case, alright, for this example, target 0, right? And so since 0 is less than the end, we'll search on the smaller side. But if the target was like 6 or something, 6 would be greater than end, so we have to search on the bigger side. So first things first, yeah, I'm just gonna say that if there's nothing, we can also return -1. And now we'll start, so finding the smallest value position. Alright, so we can use binary search for this too. The only thing is, like, we don't know what the actual smallest value would be. Like, it doesn't have to be 0, it could be like 1 or 2 or anything. So it'll be slightly different than the example that I showed in the slides. This line, technically you could just use start plus end all over too, but something would just have overflow, so prevent that by doing this. Alright, so our comparison, we're going to compare the mid value, so the value at the midpoint, to the value at the end, right? If it's greater, we're going to move start up, because we want to find the smallest value. So we can use this as an example. 7 is greater than 2, so we want to move start past 7, because we know 7 is not going to be the smallest value, to whatever's to the right of it. Because the smallest value is not in the beginning, it's somewhere in the middle. Alright. Now, after this, start will be assigned the position of the smallest value. Okay, now we want to compare the target to the value at the end of the array. Alright, so what this little chunk of code does is that it compares the target to the end of the array. So if the end of the array is less than the target, then obviously the target won't be between the smallest value and the end of the array. It'll be on the big half. So we'll just set start to beginning, and we'll set end to start. Otherwise, it'll just stay the same. Start will be at the smallest value, and end will be at the end. Now we can just do our regular binary search. Okay, so this is the condition of this. So this is how we find the target. So if nums mid is equal to target, we return the position of mid. So if the position at the midpoint is less than the target, we'll move start up past the midpoint. Alright, so otherwise, if the value at the midpoint is greater than the target, we'll move n back past the midpoint, like I explained it in the slides. Alright, so I think this should give us our answer. Cool. Okay, so we're done. This is how you use binary search.